Well, hello and welcome once again to the Waters and Stanton video channel. My name is Peter Waters and my ham radio call sign is Golf 3 Oscar Juliet Victor. I'm glad you could join me. Well, we're into 2022 now. I didn't expect the weather to be like this. It's a very mild day. It's showing 16 degrees centigrade at the moment. Quite unseasonal temperature really, but we shouldn't moan, and I suppose it's a good time to think about aerials again. Now, I've done quite a few videos on aerials, but this time I want to really go back to basics. I want to talk about a simple aerial that almost anybody can erect in their back garden, even a small back garden. Even if your back garden's only around about, what, I don't know, 20 foot, whatever that is in meters, 7 or 8 meters long, you can actually get an HF antenna in there. Now, when I start going back to basics, when I was first licensed, I didn't have much money at all. And it was really a question of scrimping and saving and going around the junk shops and buying what I could afford. Well, this video is going to be centered around an LDG 49:1 UnUn. Now, those that have watched this channel before will probably realise that a 49:1 UnUn means we're going to talk about an end-fed half wave. But the good news about this LDG 49:1 UnUn, it is very reasonably priced. In fact, the current price is $29.95, and I think I've said before that this price may well go up. So, as at the time of shooting this video, New Year's Day in 2022, it's $29.95. Now, that means to say that you can use this to create an end-fed half-wave antenna. So let's first of all take a look at this LDG UnUn and see what it comprises. Basically SO239 at one end, and at the other end you've got one terminal labelled antenna and one terminal labelled earth. I shouldn't worry too much about the earth. I mean, that terminal there is simply connected to the outer sheath of the coax there, and you can decide yourself if you want to put an earth on it. I found it made no difference at all, and particularly if you're upstairs, I suppose you could put a wire in there and call it a counterpoise, but again, I have personally not found any benefit. The only thing I would say about these terminals is you can't remove the plastic screw part there. So if you're going to use some sort of terminal, it has to be open-ended. You can't put a closed terminal on there. What I normally do is I normally bend the wire around so it fits around, put a soldering on it, solder it so that it stays in that shape, give it a bang with a hammer, then you've got a flat-ended hook type terminal to go under the screw terminal there, and that's job done. On the reverse side are 4 screws holding the plate in place. And we can lift this off. There we are. And there you see the unit. I mean, it's basically what we expected inside. It's a ferrite core with the windings on there, just a small primary winding and a large secondary winding, which gives you the 49:1 ratio. There we are. I think you can see it now. And well, as I say, it's what you'd expect to find inside. As you can see, it's quite small, fits easily into the palm of the hand, so it tucks away. I would say they rate it to 200 watts. I would say 100 watts more realistically. FT8, you can run continuous carrier, I don't know, perhaps 50 or 60 watts. Sideband, certainly 100 watts easily. CW, probably 100 watts. But it's certainly, if you've got a 100 watt transceiver, it's probably going to handle everything. But as I say, on FT8, I would throttle back to around about 50 watts to avoid saturation of the core. Now, for those that are new to the end-fed half wave, let's have a little bit of basic theory, let me just show you very briefly what an end-fed half-wave antenna is. Here I've sketched a half-wave dipole, and this curved line shows the current distribution. In the centre of the dipole we've got a high current and a very low impedance, which means we could feed this dipole with coax cable. At the far end we've got very low current, very high impedance and very high voltage. We couldn't feed this dipole with coax cable because it's a very high impedance. But the advantage of feeding the dipole at the end is that the dipole not only has a high impedance at its fundamental frequency, but on all harmonics. So if, for example, this dipole was resonant on the 40 metre band, the next harmonic would be 20 metres, it'd still have a high impedance there. On 15 metres, again it would have a high impedance, and on 10 metres it would have a high impedance. So it means to say that if we can find a way of feeding that dipole at the end, we have effectively a multiband dipole. Ignore the current distribution on the harmonics, because we'd then have several half waves in phase and we'd have the line going up and down like that. So our challenge is to find a way of feeding that dipole at the end. And the very easy way of doing it is to use a 49:1 UnUn. I've got the LDG one here, but of course anyone would do the same trick provided it's 49:1 ratio. The antenna is connected to one end of the UnUn, coax cable is connected to the other, and because this UnUn transforms a high impedance to a low impedance, it means to say we can use coax cable. So with this UnUn in place and a bit of coax cable, we've effectively got a multiband dipole. If, for example, this dipole is resonant on 20 metres, in other words it's a lot shorter, it will work as a half-wave dipole on 20 metres, but unfortunately the next harmonic is 10 metres. So you can have an antenna that covers 20 metres and 10 metres. It won't cover 15 metres because 15 metres is not a harmonic of 20 metres. There is also one other advantage, and that is that with a half-wave dipole we've normally got a fairly long length of coax cable going back to our transceiver, and any VSWR on that coax cable has to be taken into account. With an end-fed dipole, generally speaking, the coax cable is very short back to the transceiver, and therefore even a modest VSWR on the coax cable is going to have virtually no loss at all. We just need to make sure that the transceiver will match a modest VSWR, and that normally is not a problem because most modern transceivers have a built-in antenna tuner. Now, whenever I talk about end-fed half waves on this channel, I get the odd comment saying that it won't work, you need an earth, and it's very noisy, etc., etc. And these comments, generally speaking, seem to come from people who have never tried it. But I've had many comments, a lot more comments from people who say how amazing the end-fed half wave is. They didn't believe it would work. They always thought that maybe it would be noisy, and they didn't like the idea of end-fed half wave because it was high voltage, etc., etc. But when they tried it, they were quite amazed at how quiet the antenna was, how well it worked. So what I would say to those that have doubts, rather than voice your doubts, why not try it by yourself or make yourself a little 49:1 UnUn and just try it for yourself and see how well it works. And for those that say, where's the earth? Well, all I would say to you is grab an antenna book and look up end-fed ZEP. The end-fed ZEP is an end-fed wire with balance feeder at one end. Where's the earth on that? You know, sometimes in ham radio, it's far better to try something than try to fathom out and put theory to it, because theory in antennas can cause all sorts of confusion. So all I would say is if you've got a doubt about it, try it. It's the best way to find out whether it works. Now let's see how you can fit an end-fed half wave into a backyard. We've talked about a 20 metre half wave, end fed half wave, 20 metres, that's frequency, or 14 megahertz. There's a horizontal antenna there, not quite a straight line, but there we are. There's a horizontal antenna there. That's going to take up 10 metre length, which is what, about 33 feet of space. But there's no reason why you can't bend this about a bit. So let's make it a bit shorter. Make it a bit shorter, and then we'll feed it from the bottom. There we are. So we've now shortened that antenna and put a vertical leg in. And really and truly, the length of that vertical leg is not critical, provided that the total length of the antenna is still resonant on the 20 metre band. If you've got a really small yard, then you can do this. Have an even smaller section there. Put a vertical section there and vertical section there. So you feed it at the ground, run the antenna up along there and down there, and you'll get a 20 metre antenna into a very short garden indeed, a very small yard. Probably even if it was only about 5 metres, you'd still fit it in okay. And of course you can do the same with other frequencies. If, for example, we're talking about a 40 metre antenna, 40 metre or 7 megahertz resonant half-wave dipole, then that would take up a space of 20 metres or something like 66 feet. But again, if we use this principle, we can dramatically reduce it to, say, that could be, 15 metres, 14 metres, something like that, at around about 40 feet. Or we can reduce it even more. We would end up perhaps with a top section of, say, 10 metres, say 33 feet, and plus the vertical sections. The critical thing is that the total length of the antenna must still be resonant. So in these cases here, we're feeding it at the bottom. It doesn't make a heap of the difference really. Just put the balun, or the UnUn rather, at the bottom of the antenna. But of course you can also do another thing with it. We can make it what we call an inverted L, which is quite an interesting antenna actually. But we can do it in a rather unconventional way. We can now put our UnUn at that end. So we feed it from, say, an upstairs shack, run the aerial down the garden, and then have a vertical section there. Again, the critical thing is that total length will be a half wave on the lowest frequency. So there's a lot of possibilities for getting this end-fed half wave into quite a small garden. And there's yet another possibility. Let's suppose that you were in a hotel or your own house actually. That's an outside wall, and that's the roof. Then we take the antenna from an upstairs window, say up there, and we can run it down to almost ground level as a sloper, like that. And that's a sloping antenna. That's ideal for temporary operation, provided you're in a house. You don't need any supports at all, you just need a stake to go in the ground. And I'll show you that very briefly now. I've used this sort of installation many times, both at home and when I've been away, and it always works. I'm not sure whether you can see this. The wire comes out of the top window there, comes down here, down the ground. It almost goes down to ground level. And you see I've put a little stake in the ground just to anchor it in. Bit of cord going up to the insulator. And the insulator sort of keeps it around about, 20 or so centimetres, 25 centimetres above the ground. Now, of course, if you've got a tree in the garden or something like that, then you can raise the end. But if you have the antenna like this, it's what we call a sloping antenna. Probably the house behind it will act as a reflector and give it a bit of directivity, but don't take that as absolute, because in a small garden you're never quite sure exactly what's going to happen. I've been using the Zygo X5105 little 5-watt transceiver for all my operation over the Christmas period, just to get back to basics, low power, and of course test the transceiver out, because it is a budget class transceiver. But and also to keep the cost down for newcomers, this transceiver actually has a built-in VSWR meter and graph, and I've set it up so that the SWR meter is on the menu item there. If I press this now, it's going to scan the band and give me an SWR curve, and also show me the best VSWR reading. Now it's completed its scan. I've switched to 28 megahertz now, and we'll do a sweep on that band, see what we get. And as you can see, the VSWR is very low indeed. So 10 meter operation is very easy with this antenna. So you've got 2 bands to operate on. So there we are, that's a very simple antenna, covers 20 meters. It will also work on 10 meters on its second harmonic. And of course, if you've got a larger garden, then you can double length of this antenna so that it will then cover 40 meters, 20 meters, 15 and 10 meters. And as I say, it's a very low cost investment for an antenna that will really work extremely well. I've got a horizontal one up in the air, which I've had now for about 3 years. And it's not particularly high, it's only about 25 foot above the ground, which is what, I don't know, 10, 12 metres, something like that. No, it's not 10 or 12 metres, is it? It's something less than that. It's about 7 or 8 metres, oh dear, conversion. But it works extremely well. I regularly work across to the US on 20 metres, and of course with 15 metres and 10 metres opening up, as of course, as well as the walk bands, it's a chance to work some DX. But do remember, of course, that an end-fed half wave, whilst it is a multi-band antenna, it will only work on the harmonics. So you choose the lowest band that you can fit into your garden, and then on every harmonic it will actually resonate quite well. And if you've got a little bit of an SWR, you can always trim it off with the internal antenna tuner in your transceiver. So on this New Year's Day, it's a chance for you to experiment with a low-cost antenna, and I've had a great deal of fun, and I always enjoy messing about with antennas. And I think that, you know, as I've always found out with antennas, you can model them and you can mess about and read about them, but the best way to find out whether it works or not is to actually make one. And when you're not investing a lot of money, there's no excuse for not experimenting with the antenna and seeing what you can get. And as I say, if you've got more room, you can put up a horizontal version of this. I would suggest that if you do put up a horizontal version of this, you might want to put the UnUn inside a plastic box. As I say, they don't really mention whether it's waterproof or not, but anyway, it's up to you. Certainly for a few weeks outside, I don't think any harm would come to it at all. So, another video. Enjoy ham radio. Thanks for your support, by the way. Don't forget to press the subscribe button. And, well, as usual, I'll see you in the next video. In the meantime, take care. Bye for now.